crossing the streams, leveraging Pulsar I/O and Pulsar functions together with Spring Cloud Stream. My name is Chris Bono. I'm a software engineer on the Spring team at VMware. I'm also Apache Pulsar committer, and this is my GitHub and LinkedIn info. Today, what we're going to cover is really an intro to Pulsar. We're going to give you an intro to Spring Pulsar, and we're going to talk a little bit about stream processing and with respect to Pulsar and Spring Pulsar, as well as Spring Cloud Stream. We're going to give a demo of how we can do stream processing with built-in Pulsar capabilities or with Spring Cloud Stream, and we can kind of mix and match and use these together. The slide deck's going to be pretty basic. We're going to go through some things really fast. If there's questions at the end, we can cover them, but we want to get mostly to show the demo. And so what is Apache Pulsar? So a lot of people are not super familiar with Apache Pulsar, but a lot of people know what Kafka is. And so I always start out by saying, Apache Pulsar is very similar to Apache Kafka. Kafka's been around longer. Pulsar is a little bit newer, and it's a messaging system based on pub/sub model. It's built in from the ground up. It has multi-tenancy, geo-replication, a lot of features. If you were to, and I stay clear away from Kafka is better than Pulsar or vice versa, but really Pulsar has, if I were to go back in time or forward in time after using Kafka, Pulsar has a lot of the features that I think would be built in from the ground up. And so that's what we're going to go into about as far as what is Apache Pulsar. That's all we need to know today for what we're going to do for the demo is you have producers and consumers, you have topics and a broker, you send messages, there's a subscription, they receive messages. And so what is Spring for Apache Pulsar is a framework for taking Spring-based applications and making it easy to use Apache Pulsar. It also brings Apache Pulsar into the Spring messaging ecosystem. We have support for AMQP and JMS and Kafka, but we had a gap in supporting Pulsar, so that's also what Spring Pulsar solves. And like any other Spring project, the main goal of it is to increase developer velocity and developer experience, to make your life easier when you want to get started with something and just run. And so these definitions of stream processing are loose, and so don't shoot the author, or don't shoot the presenter. Stream aficionados can get really deep into, that's incorrect, that's not actually what a stream is. And so for today, a stream is an unbounded continuous set of data. We're going to think of it as records from time 0 to time 10. And a stream processing app is a application that has computational logic on that stream in a stream processor topology, where a stream processor is a record comes in, we apply operations to it, and a record goes out. A specialization of that is a source, and that's on the leftmost side of the pipeline. There's no upstream processors from it. It feeds data into that graph. And likewise, a sink is a termination at the other end of the pipeline. It feeds things. It has an upstream processor, but no downstream processor. Ends up looking something like this in the simple sense. And there at the bottom you see Pulsar. That could be any other, point-to-point or any message system at the bottom. And so Pulsar by itself, it has support for stream processing, and it does that in form of it has an offering called Pulsar I/O, and what Pulsar I/O is a set of connectors that lets you easily feed data in and out of Pulsar sources and sinks. And then also it has a serverless lightweight framework for Pulsar functions, and you can imagine you basically take your Java function and you ship it up to the Pulsar server, and it runs. By serverless, what we mean here is it's very similar to AWS Lambda, where all the functions and the connectors, they execute in the Pulsar space. They don't execute on a separate application node. And if you're used to Spring Cloud Stream, that's not the case. They execute outside on their own application. And that'll become clear when we look at a couple diagrams in a minute. Also, there's quite a few built-in connectors, and so you can get started fairly easy, and allow you to import and export data from quite a few common systems. And here's the list of their built-in source connectors. We're not going to go into the details, but you'll see that RabbitMQ is highlighted. We're going to use that in the demo day to actually source records in from Rabbit to Pulsar. Here's the built-in sync connectors, quite a few of them. Likewise, we're at our sync. What we're going to do is use the HTTP sync and go to a webhook in Slack to send messages out of the system. Okay, so talking a little bit about Spring Cloud Stream. The purpose of this talk is to cross the streams and show how we can use the built-in functionality of Pulsar functions along with Spring Cloud Stream. So Spring Cloud Stream is a framework for building message-driven microservice-based apps. And the difference is based on what we were talking about with Pulsar functions, is that these Spring Cloud Stream apps are actually applications that run in their own space. And they're just Spring Boot apps, and they leverage Spring Cloud, also leverage Spring Cloud Function, and lets us bind POJO functions to, these are our stream processors in Spring Cloud Stream. There's several binders when we talk about binding POJO functions. Spring Cloud Stream has the ability to bind the POJO functions to either Rabbit, Pulsar, Kafka streams. There's quite a few more. I'll talk about the out-of-the-box stream processors in a minute, and that's why there's a little red highlight there for a reason, but let's go look at these POJO functions for a second. This naturally maps to a source. Spring Cloud Stream has the ability to take this simple Java function, and with a little bit of configuration, all of a sudden it'll write messages down into Pulsar or Kafka or any of the other binders. Likewise, the processor will look like this. There's a Java util function. It'll get this first parameter, this string. It'll bring that in from a topic, and then you'll process it and write the result out to another topic. And this, likewise, the consumer does the opposite. It'll receive a message from a topic and do something with it. We jump back here to our original diagram for a second. This blends really well to those. Each one of this represents one of those functions that we just went through. Okay, so the caveat on the built-in processor apps for Spring Cloud Stream is that those binders that I was talking about, the Spring team, we maintain a set of built-in applications, and what those are is they're Spring Cloud Stream applications, but they're built to a certain binder. And so we have them currently built to Rabbit and Kafka, and we're looking at adding Pulsar as well. And once we do, this list of out-of-the-box apps would be available for Pulsar as well. It's really just a matter of configuration and setting it up and building the app against it. There's quite a few of them. The other interesting piece is that the stream applications, we have quite a bit of processor apps that we don't have in, you didn't see any processor apps in Pulsar's built-in. We saw that Pulsar has the built-in sources and syncs, but no processors. You can do actually some interesting things with the processor apps. And here's likewise a set of sync apps for stream applications. Okay. So at this point, we're at the demo time. And we're going to go through a little scenario here. Is that legible? No? Okay, so let's say our team is the customer success team. We're over here in this Pulsar space. One of our sister teams is, say, user signup team. And what they gather user signups from the internet or from our website, and they drop it into RabbitMQ. Totally contrived small scenario just for the purpose of illustration. And so what our mission, if we accept it, is to take Rabbit records from the user signup, get them over here to Pulsar, because that's our team deals, that's where our system runs against. We want to process those records and do some filtering and forwarding and filtering and conversion. So if it's an enterprise signup, so the users will be one of like basic, enterprise, or standard. And so if it's an enterprise user, we want to convert that to a customer. And then we want to notify our customer success agents, hey, go onboard this customer, and we have a new customer in the system. And so what we want to do at this point is leverage we want to mix and match how we use the Pulsar functions, sources, sinks, as well with Spring Cloud Stream. And so one way to solve it is this. We'll drop in that Pulsar Rabbit source, right? That'll bring the records across from Rabbit to Pulsar. Then we could use a Pulsar function. You notice where that box is, it's still inside of the Pulsar space. That's because it runs on the server. But what we want to do for this demo is instead do this. If we go back to here, you see the difference? Spring Cloud Stream apps run outside in their own space. That's why they're microservice-based apps. And would we recommend, hey, let's do as many technologies as we can in a real system? No. This could be a case though where you have, imagine that we're not just if print enterprise then create and forward. This could be some really complex logic that was already built in the Spring Cloud Stream application that did some kind of ranking and ultimately spit out the result in this topic, and you don't want to touch that or reinvent the wheel. So it'd be more of an integration pattern to do something like this. And plus, it's the topic of this talk, so we're going to do two things here. Finally, we'll drop in a Pulsar HTTP sync. And what this will do is the HTTP sync takes from that customer sign-up topic, it'll take the JSON payload, and it'll submit it, it'll post it to some HTTP URL you give it. And so in this case, what we did is I just registered a Slack webhook, and I had to mangle the data a little bit, and so I'll show you all the caveat there as well, and it's not something we would want to do. It's kind of like, feels like there's a little bit of view logic built into the model, but I'll show you in a minute. But the cool thing is when we do this with very little code, what we'll see is we're going to start, and also what we'll do is we'll generate some user sign-up data over here on the leftmost side in Rabbit. And so every 3 seconds, we'll drop a record in, and we'll watch it. We'll watch the ones that come out to Slack be filtered to enterprise. Yes?
Why do you have RabbitMQ and Pulsar at the same time? Because RabbitMQ is technical JMS, right?
No.
Pulsar is going, no?
No.
Okay.
AMQP.
Yeah. And also really, yeah, this would just be, imagine there's a system where you have two teams, one is collecting data into Rabbit, and we need to get it into Pulsar for whatever reason.
I would actually do it differently, because in Pulsar you can consume it multiple times. So you put it once and use it as many times as you want, but then like in RabbitMQ is more like a single.
Correct. Correct. This is definitely just for illustration purposes. Yeah. So you may have
something sitting in Rabbit.
Yeah.
Migrating to Pulsar.
Yeah.
So you need to take the messages from Rabbit and put them.
Yes. Yeah. Cool. Cool. All right. No. So let's go ahead and let's get to this. Let's see what it takes to do this in code. So what we want to do is start out at start.spring.io. This is where we can bootstrap our Spring Boot based applications. We're going to do Gradle, Java, Spring Boot 330 M3. We're going to go to com. We'll call this com Acme Pulsar. No, com Acme, and we'll call this Pulsar demo. We'll back off this package name a bit. We're going to generate. Nope, I don't want that one. That has nothing in it. Okay, so let's do Pulsar. Let me do something real quick. Pulsar demo. Okay. And so what we'll do here is we'll include Pulsar, we'll include Spring Cloud Stream, and then we're going to also include AMQP so we can easily generate that data into the Rabbit on the leftmost side. Okay. And so instead of looking at this here, we could explore. I'm going to go ahead and generate, and we'll pull it up in IntelliJ. Okay. And so we're going to copy over. I'll increase the font. Don't worry. Actually, so let's look at build.gradle first. Is that legible? All right, cool. All right, so what we have here is our shell application. It's using Spring Boot 330 M3, which uses Spring Pulsar 110 M2. I'm going to chop out some of these dependencies. We don't need all of this. We don't need the Rabbit binder. Don't delete your test dependencies in real life, but we're going to just remove extra stuff right now. Make it simple. Okay. So at this point, we have the AMQP starter. This is to generate data into that leftmost side. This is our Spring Boot starter for Pulsar, and this is the Stream Cloud Stream dependencies that are required. And we've also got this Docker Compose file over here that we're going to start and use. It's going to hop up in Pulsar. One thing with the connectors, you'll notice I'm mapping the connectors, this volume here. I have 2 of the connectors that we're going to use over here. You can't really see it. They're in the form of NAR files, and that's a format for the Pulsar connectors. And I have these ready, and so what we'll do is when we start this up, it's just going to map those in. Pulsar will see them, and we'll be able to use them. Another piece that I copied over from a template project was this model. And so this is our user sign up. There's a sign up tier, free, basic, enterprise. There's a first name, a last name, and an email. That's all we'll demonstrate today. The customer sign up is interesting. And whenever you do a webhook to Slack, it needs 2 things. JSON needs to have a thing called text, an entry called text, an entry called blocks. And so blocks is the kind of generating the card. So ideally, we wouldn't create this and store this as our forwarding, as the converted record. We would do another step that would transpose it. But for our purposes, this is just going to take that user sign up and put it into a form that will plop out on Slack for us. Okay, so at this point, I think we're good. Let me adjust this. Well, we can let's go ahead and start up our server. Okay. Cool. Let that thing do its business. And so what we'll do, come over here, I'm going to rename back to YAML. Okay. Let's get going on this. Okay, so I don't type this fast. There's a few things in here that I've set up as IntelliJ Live templates. One, so y'all don't have to watch me hunt and peck for keys, and just so we can streamline the demo a bit, but we'll go through them big steps. These are just some convenience functions so I can log in color so it's easier to see whenever something's coming from one system to the other. Okay, so the first thing we want to do is, let's just kind of write out our steps here. Step 0, generate data into Rabbit user sign up queue, right? So we're going to do that first. All right, step 0, just kind of outline what we're doing. Step 1 will be source data from Rabbit into Pulsar, right? Using Rabbit source. Right. Step 3 will be process user sign up and convert to customer sign up. Sign up's an interesting word to type, as I've found out over the last few days. Step 4 is finally sync data, customer data to Slack. And that's our goal. And we'll go through here and put pieces in here as we go. All right, so what do we need to do for step 1? I know that I'm going to use the little library called jFairy to generate the test data. And so it's not in start.spring.io, so I've got a little thing here to add it in. I'm going to come over here and also log level minimize, get rid of some extra logging. And I think at this point we're ready to go. So we're going to create this sign up generator, and it's going to be a service, Spring service sign up generator. Cool. And we're going to make it a service. We're going to also enable scheduling, because what we want to do is have a method that goes every 3 seconds and drops in new data. And watch how fast I can code. Oh, okay. So we'll step through here first. There's this, we have a random, and this fairy is that jFairy library I'm using to generate test data. It's actually pretty cool, pretty realistic data. We're going to use this Rabbit template to source the records into Rabbit. And here's our schedule method. After it starts for 5 seconds, we're going to, every 3 seconds, drop a new record in that queue. We just call generate, and we call it convert and send, and we log the fact that we did it. And generate, you can see just as fairy.person and adds some, turns it into one of the records and goes on with its business. And let's see, at this point, so that would every 3 seconds put a record in the leftmost side, and I think we've solved step 0 at that point. So let's do something interesting with it. So we want to source that. We want to add one of those pulsar sources. And so the way that you do that is as so. So pulsar source, this class right here, this is a Spring Pulsar abstraction. Because the program model, like I said, for pulsar sources, because they have to be shipped to the server, you use the pulsar admin and you say, I'm going to use this, I would like to use the built-in RabbitMQ to source records from my RabbitMQ here, this queue there, and ultimately drop them down into the user sign-up topic. And then you tell the pulsar, through the pulsar admin, you tell the pulsar server this information, and it goes and sets all that up for you, and on startup, it starts sourcing data. Yes? Absolutely. Yeah, this is strictly so to bring it, I went that route, but I wanted to bring it out so we can step through it and just keep it simple. You can actually use Rabbit properties if you're using AMQP and get it auto-configured. Okay, so that's it. For at this point, we will go back to that diagram. We've dropped in the pulsar source, and technically, when we start the server up, we should start every 3 seconds bringing records across. To prove that fact, what I'm going to do is I'm going to add a pulsar listener, so this will just show those records from that topic. And so let's say topics equals user sign up queue topic, sorry, and subscription type, shared. Because the pulsar source also looks at that topic, we want to keep it shared so we don't get into different people eating the records before we're done. Okay, so void log user sign up. There you go, user sign up. Log info, and let's say blue, and we'll say from pulsar user sign up topic. Okay. And then we'll go user sign up. Cool. And so let me check my checklist here. At this point, I think we're good. We're going to go and hit this play button and see what happens. Our server's back there waiting for stuff. There we go. Okay, so the magenta you can see is to Rabbit. That's our little dummy generator. And then the blue is from Pulsar. And so things are feeding in. That's at step 1. Okay, I'm going to go ahead and stop at this point, and we're going to go to the next step. Did that stop? Yeah. Okay. So step 3 actually, process the user sign up and convert it to customer sign up. So we're going to use Spring Cloud Stream in this step, and so what that would look like is first we create a bean of a POJO function. We want to take records from the user sign up topic, and we want to process them and then ultimately drop them into a customer sign up topic. The input parameters, comes in from, goes out to, if you remember back to that diagram. And there. And so what that'll look like is customer sign up processor. Remember that name, it's important in a minute. And Spring Cloud Stream works off a naming convention by default, which makes things really simple. And so customer sign up processor. And so what we'll have is something like return this. We're going to take that input record, we're going to create this function. Let's save some time here. You don't want to watch me code. Okay. Boom. Okay. So, magic. Yeah. Much better. And so what we do is again, the input to the function is this user. We grab its tier. If it's not an enterprise, we just log saying we're dropping it. We return null. That results in nothing. Finally, if it is one of those enterprise ones, what we want to do is convert it to a customer sign up, log that fact, and then return it, which ultimately sends it outside of the function, and the binder pushes it down back on the topic. And so if I were to push the play button right now, nothing would happen. Because while it's pretty magical, we still have to say a few things to tell it how to bind this input and this output. And so we do that over here in application YAML. And so first, spring.cloud.function.definition. We really don't have to do this when we have one function, but I want to just go through it for posterity. This is that naming convention we talked about. This is the name of that Java function. If my function was called foo, this would be called foo. The next thing we have to do is bind those parameters. So Spring Cloud Stream bindings. And this is the one that's, boom. Okay, notice a naming convention. Customer sign up, or foo, input of 0. This is that input argument 0. This is the output argument 0. So user sign up, customer sign up. Well, what is that? In this destination tells it where to get it from. Go get that input from the user sign up topic and use native decoding. That just tells Spring to say, don't try to do your built-in messaging and conversion. Use the Spring Pulsar facilities. Use the Pulsar facilities. And so one more little piece we also have to share with the system is that we also have the concept of binder-specific settings. And so Spring Cloud Stream, Pulsar bindings, and we're working at getting rid of this. We can really imply this from the method types. We shouldn't have to go and do this step really. This tells it, this input type is of user sign up, but we know what it is because we can figure that out in Java. So this is it. So we've mapped now the topics to those inputs and outputs, yes? Yeah, so in -0 this is customer sign up processor. And if we go back to here, that's this right here. And the N0 is this.
Well, instance for input.
Yeah.
0 is
position.
We support multiple functions with multiple arguments. So
Yeah.
99% of the time it's always 0 because single argument, like a standard function, single in, single out.
Okay.
But for the reactor, we support functions with multiple inputs and multiple outputs. Okay. So for those bindings, you could possibly see 1, 2, 3, 4.
Yeah. For our purposes, if it was like this, it would be very clear, right? In 0, out 0, yeah. So just mentally think of like those fall off as defaults at this point. Yeah, because it's much easier to follow through with. So, cool. And now the theory is if I push the button now, we're going to see data feed into Rabbit to Pulsar, and then we're going to just, one more time actually. That's why I talk through these, because we wouldn't really see much of anything. We want to actually log it as well, the fact that it came to the topic. Okay, so topics now is customer sign up topic. And then, again, a subscription type shared. Okay, let's go to void log customer sign up, and we'll have customer sign. Why is it not signing itself? Boom, boom, boom. Log info. Let's do this one green. It's like good. Okay, so from Pulsar, customer sign up topic. Plus customer sign up. Okay. Now the theory is if I push the button, we'll see the things go all the way from left, almost out the right side of the pipeline. Okay, so let's come up here. And boop. Oh, not debug. I probably have a bunch of breakpoints. Hopefully not. Let's turn that off. Okay. I just mute. I don't even want to see where it stops. Ever do that where you go run it in debugger and you're like, what was I looking at? Like it's down deep and so level of the core, it's everywhere, and you remember why? Okay, so you can see, the green ones are the enterprise customers that are coming all the way down to that customer sign up topic. The red ones are the ones that we drop, And so let's go ahead and stop real quick, and let's do the final step here. Let's push those out to Slack so we can tell somebody, hey, go do something with this. It was pretty cool because what I didn't want to do is I wanted to show something external, something neat. It went to Slack versus look at my log file, and I was just exploring through all the syncs. I haven't used the sync before, and I was like, oh, what can I do with HTTP sync? Literally, and thought, oh, what does Slack have a webhook? In 15, 30 minutes, I was able to get something going. I was like, it's cool. It's really cool. Not because I'm so brilliant, because of the fact that it was easy to use the stuff and wire it together. There's very little to do. And so let's go ahead and let's do a CTS HTTP sync. Boom. And so we'll kind of look at this for a minute. This says, likewise, the Pulsar, we under the hood, we tell the Pulsar admin, I would like to use this built-in HTTP connector. I want to sync things from this customer sign-up topic to this, this URL. This URL is over here in this application default, kind of hidden. I don't check it in because I don't want to show it to y'all either, because then Slack's fun. They're watching. If you check this in, the webhook into your URL, immediately you'll get an email saying, we're deactivating your webhook. We saw that you did something bad and uploaded this webhook to your GitHub. I was pretty impressed. It was really quick. And so let me import this. Now the theory is if we push play, we'll see things in here. And so customer sign up incoming topic. I've muted things out after practicing. And let's push the play button. I got to watch it first. You can see here it's creating the sync. So there we go, green. Yay. Old Nathaniel Davenport, whoever that is. So what? Glenn, yeah. Oh, we could do that.
That way I won't feel so low.
Yeah. And so there's another one drop out, and it's Natalie Parrish. So we could watch this. We've seen the novelty. There's one, there's N, they're the same thing. It's just going to keep piling up. But the point is we were able to string together this little, fictional pipeline going from Rabbit to Pulsar, processing it, dropping to another topic, sending it out to Slack, and I mean, there's not a lot of code to it. Pretty cool stuff. Yeah, that's it. I stopped it. That's the demo. And so we have plenty of time to talk about whatever. I think we have 10 minutes, something like that. Yep.
Talk a little bit about the geo distribution of the Pulsar, the replication.
I could, but I would just only confuse you. I have not used the geo-replication in production, and so it's definitely more of the complicated feature. But afterwards, I can put you in touch with somebody who knows more about it.
Can you talk about concurrency then? How do we restrict how many of those events can be consumed in parallel?
How many of those events can be consumed in parallel from for instance, from the topics?
Yeah, from the Pulsar side. Say I've got only 10 connections in the running Spring Boot out.
Yeah.
How do I make sure I'm not got 100 that are trying to consume?
Receiver queue size. There's properties that you can set inside of Pulsar. And so Pulsar, what was really cool, it also has a really flexible subscription model. That's another key differentiator from Kafka, is that you can adjust Pulsar and configure it to look either like a queue or typical just from regular streaming messaging. Yeah, so you can restrict that through. There's something you could set, for instance, if I set a subscription type of shared, and I have a set of consumers against that, and so the way that the thing that's pulling right now, the actual the Pulsar listener is what we're seeing. Which let me go back to the diagram so I can make sure I'm answering the question here. Here, let's do this.
I think the question is really like in GMS, topic versus queue, where one is a single consumer, one is a multiple consumer, right?
Well, no, so if I think about, in your example, if that RabbitMQ side was generating 1,000 messages a second,
Yeah.
and I fed them into Pulsar, and there's no way I can process that amount because of my business logic. I've got to have some level of infrastructure. I've got to be able to not take ownership from Rabbit or Pulsar, I'm assuming it's Pulsar, and I've taken ownership of this event. Because if I needed to scale 10 copies of your application, all that fun stuff of how do I get beyond the simple app?
Yeah. Yeah, well, there's a bunch of different configuration options. So if you were to do that at the Pulsar source, you can set configuration properties for the consumer to set up the receiver queue size, and this one is very simple. But also, there's a bunch of function or connector related properties so that when it goes to Whenever it goes and deploys, you can set up different function workers on Pulsar side to also control how many workers are there pulling off of that. And yeah, that's about what I know about that level of the sourcing. Likewise, on the Spring Pulsar side of things, though, like when we do the Pulsar listeners, when I was doing those, that's another consumer of each one of these topics, and those scale via there's a concurrency attribute that you can use on that Pulsar listener to set how many of these listeners you want to hit that topic. Yep. Yeah. This is a very basic. It's the hello world of left to right, right? And so yeah.
So does Pulsar also follow similar semantics as Kafka in terms of consumer groups, partitions within the topic? Does it follow similar things?
Yes, it is very similar. If you've used Kafka, going to Pulsar is pretty much I get that, I understand that concept. And so there's partitions. You don't have to have partitions, right? So, and there's also built-in tenant and namespace concept in Pulsar as well. But yeah, for me, I ran before, in a past life, I ran a production workload of Kafka streams. And so I had a production expertise with Kafka and Kafka streams. Pulsar, I've picked it up while at the Spring team. I have not run production workloads with Pulsar. And so I'm not going to sit here and tell you, I've out in the battlefield, I've ran all this Pulsar workloads. So it's a different thing when you write a framework for something and you've been up at night trying to wonder why things won't rebalance properly and you hate your life. And so these are two different things, but yeah. Concept are very similar.
Sorry to monopolize. Another question that he and I work together, so we're going to tag team up.
Nice.
So one of the challenges we've got, not just with Kafka, but with JMS and all of those, is the idea of multi-tenant fairness.
Okay.
We talked about Pulsar multi-tenant. Does it have anything in a fairness model where if I've got one client who's just emitted 1,000 events, I don't take all my resources consuming them for the guy who just emitted 5 events?
So again, with consuming fairness, really, right? Yeah, and so I guess multi-tenancy in that case would be a bit different, right? Because multi-tenancy is ideally that my data is my data, your data is your data. And so again, with the consumer fairness, you would have to set up, there's ways to do that. So there's different load balancers that you can set up. Oh, no. And yeah, there's different types of load balancing that you can set up to share amongst the consumers.
And would that be in Pulsar or would that be in the Spring?
Oh, that level would be in Pulsar side. Yeah, Pulsar side. Spring. So what we provide with Spring Pulsar really is, I showed y'all the Pulsar listener. The Pulsar listener, the annotation just creates what we call a message listener container. That we can have N of those, and each one of those accepts a set of configurations. So you can tweak each one of those consumers. That's all that's under the hood of those containers is a consumer in a loop getting the data off the topic. So you can shed all this magic and there's just consumers, and you could tweak those and set the properties accordingly to each one. But Pulsar is extremely flexible in this sense, and I've yet to find out, like, if somebody asks me something, can you do this? And most times you can. Yeah.
What about failover? How does this, like, if you go with this architecture, with the fast sinks and Pulsar like source?
Yes.
How would it handle the failure in between the system? For example, let's say Slack disappeared. How the system would behave?
And so they do give a guarantee on the semantics of exactly once. You can set it up for exactly once, at most once, ideally once. And the function, the Pulsar function, when we look at this, let me go to this graph right here. And so this was if we were to solve it with a Pulsar function instead of Spring Cloud Stream. And so the Pulsar function gives you even tighter consume, apply, publish semantics so that you have that transactional, I know that I pulled something off, I did something, and I pushed it to where it needs to go. That's the common use case. It solves that really well. Now, the sinks and sources will adhere to what those guarantees based on what the external systems that they're built on, and really it comes down to the implementation of the source or the sink connector.
So the built-in connectors support that those semantics.
As much as they can, to the extent that the system that they're sourcing or syncing to. And each one of the connectors, but it's part of their API to tell what guarantees it provides. So you can ask a connector, do you guarantee exactly once? And it'll tell you yes or no. And so there's some metadata involved with each one of the connectors.
One last question
Yeah.
from my side.
Sure.
I don't know if it's fair to ask. What makes you to choose Pulsar over Kafka?
And so I truly love Kafka. I love Pulsar. I love AMQP. And I'm not giving you this answer because it's like, oh, it's a political answer and it's everybody. It's not that. It's that really, you know, our passion is about making something easier to use as a developer. I definitely will. If I go through some pain, in general, if I go through some pain, I don't want anybody else to have to go through that pain. So that's what it's kind of also the open source spirit is like, if I can fix this for one or a million other people, I'm going to do that. And so we had a gap in Pulsar, and I'm interested in messaging, and that's kind of where the project was born. And so I steer clear of Kafka versus Pulsar because Kafka's been around longer. It's running in more production workloads. It's probably more stable. It's been around, and that's the way things are when they've been around. And there's so much Kafka. You know how it is getting off of Java 8. Have anybody still on Java 8? You know, and so it's right. And there's some apps that are, and maybe there's some that aren't. And it's the same thing. Even if you wanted to, they're both great tools. Yep, it is a fair question.
Do you know what is the penalty for going exactly once implementation? Because once you basically get it exactly once, you wait until everything is getting committed out across the places. And it might not be sequential like in Kafka, but what would be the penalty from the performance perspective?
So the transaction model is actually different in Pulsar than Kafka. It's done quite differently. It's actually more I use the term flexible, but it really and so we've just added transaction support in Spring Pulsar for Pulsar, and it's coming out in Spring Boot 3.3.0, which is in May. Another month. We're RCing next week. And so the Pulsar transaction model is the way that works. And also go to Pulsar docs and look at the transaction model. They have a really good write-up of how it works. But you basically enlist everything in. So I would say, okay, I'm going to start this new transaction, and it registers with the transaction manager in Pulsar. And then what happens is, as I go and I say, okay, I'm going to send this message, and you pass in that transaction ID. I'm going to consume, and when you acknowledge, you pass in that transaction ID. I'm going to acknowledge another message. I'm going to acknowledge. I'm going to send. I'm going to send. I'm going to acknowledge. I'm going to send. I'm going to acknowledge. And you could set up this nasty web of this would be not good because it'd take forever to do. But what happens is at the end, when it goes to do that commit, it goes to their protocol, and it'll take everything and say, okay, did this work? Did this work? And it reconciles that web of things that are enlisted in transactions. So you can get it really complex. And I know there is some things in there that actually is good for performance. But as far as you would want to use exactly once when your business demands require it, because of course it's going to be faster to do nothing and just fire away as fast as you can asynchronously. So it depends on the use case. Yeah. But if you're interested in transactions, it's actually it's a good read, and it's under you'll find the Pulsar docs out there, and it's an interesting it's technically deep enough. I was surprised they put it in there in Pulsar docs because there's sequence diagrams, and if you like sequence diagrams, and you have an hour to waste of your day, maybe on the flight, back. Yeah, because that way I say, okay, I understand what it's doing now, right? I'm definitely one of those type of people. Yeah, thank you. Cool. Thank you all.